Hey, Algebra 2 Honor students, this is going to be Unit 13, Day 3. Today we're going to be talking about some evaluating practice. And before we get there, let's do this question as a warm-up. So if you want to write this down in your notes, it says if sine of x equals negative 3/4 and tan of x is greater than 0, determine the value for secant of x. So a couple things we're going to have to digest here to get started. One of them being that sine of x equals negative 3/4, and then they tell us this additional information that tan of x is greater than 0. So why do we need that information, I guess is the question. Well, because you're my all-star trig class, you know that sine of x could equal a negative ratio in two different places, right? It could be negative in quadrant 3, but it also could be negative in quadrant 4. All the functions are positive here, and s in quadrant 2 means sine is positive there. So therefore, the reason why we need this additional information that tangent is greater than 0 is it's going to narrow us down to just one of those two quadrants. And if tan is greater than 0, that means tan is positive. Well, out of these two locations, which one is tan positive in? Definitely quadrant 3. Quadrant 3 is the winner for sure. Okay, so if sine is negative and tan is positive, what I want you to do in this warm-up question is draw a triangle that's in quadrant 3. So angle X is an angle that terminates in quadrant 3. If you want to draw the whole thing, you can do that. It would look something like that. So I'm going to label the X part right here. And then we know that the ratio for sine is opposite over hypotenuse. So you're going to label the opposite of the X negative 3, and the hypotenuse is a 4. And then last but not least, in order to find secant, you will need to know this last missing side. And that last missing side, of course, will be an application of Pythagorean theorem. Be a little bit cautious here. When you see a 3 and 4, maybe you're used to this pattern, but 3, 4, 5 is a common pattern within right triangles. It's called one of those Pythagorean triples. That's only if 5 goes on the hypotenuse, though. So you do have to follow and do something like this to figure out what this last missing side is. So that would be 9 plus b squared is equal to 16, and therefore b squared equals 7. So we get b equals the square root of 7. We're going to put radical 7 here. But the last thing that I want you to think about is that that is going to the left. And when we plot a point in quadrant 3, we're going left and down. Both of those coordinates would be negative. So we do have to label that adjacent leg as negative radical 7. Okay, it's not because the length is negative. It's really just more for directional purposes. So how would I do secant of the angle x? Secant would be hypotenuse over adjacent. So the hypotenuse is 4, and the adjacent is negative radical 7. Now, it didn't say anything about this, but I'm going to do it anyway. If it had said to do this in simplest radical form, we wouldn't leave radical 7 in the denominator. We would multiply the top and bottom by radical 7 to rationalize the denominator. You don't even necessarily need the negative with that unless you want to. It's kind of up to you. But the final answer when rationalized would be negative 4 radical 7 would be in the numerator, and then 7 would be in the denominator. And that's in simplest form now. If it didn't say anything about that, you would have stopped right here. And you could have stopped at 4 over negative radical 7. So just kind of connecting a few pieces from yesterday. Hopefully this made sense based on what we now know about all-star trig class, determining the quadrant, finding that missing side, and then now what we know about reciprocal functions, secant, reciprocal of cosine. All right, today we're going to look at a little bit of new information as it relates to evaluating practice. And within evaluating practice, we're going to follow certain steps. So step number 1 is to sketch the angle. Okay, and this will make more sense when I give you the first example, but we're going to sketch the angle first. And then step 2 is once you've sketched the angle, find what's called the reference angle. This is something we saw for the first time in yesterday's lesson. When we're evaluating, we're going to find that the reference will be either 30, oops, that's supposed to be a 6, 30, 45, or 60. Those are the three options. Because if it's a 30, 45, or 60, then we know how to label the sides. We might as well do that off to the side quick to remind ourselves that in a 30, 60, 90, now in our notes from day 1, I had these sides labeled in terms of x. I'm going to let x equal 1 because that's the easiest value we can choose for x. And therefore, the ratio of the sides would be 1 radical 3 and 2. Similarly for the 45, 45, 90. If x is 1, it would be 1, 1 radical 2. This way, when I go to list some ratios in the end, they'll already be reduced for me. I don't necessarily have to reduce any fractions if we let the value of x equal 1. All right, so that's kind of a big step. Find the reference angle. Once you found the reference angle, then you're going to label the sides. So you're going to label the sides because if it's 30, we'll know what to do. If it's 60, and then finally, if it's 45, we'll know what to do. And then finally, use SOHCAHTOA. And as a check, make sure you check with all-star trig class, because we want to make sure that our answer is either positive or negative in the end, and hopefully we'll be able to determine that pretty easily. All right, well, there's a lot going on here, but hopefully we'll be putting a lot of different pieces together from what we've seen over the past few days now. If I ask you to do sine of 240, within this evaluating, I want you to come up with an exact answer, which means don't touch the calculator at all. So to do sine of 240, first thing is to sketch the angle. 240 is definitely in quadrant 3. So you're going to sketch an angle in quadrant 3. When you draw on the terminal side, what I'll ask you to do is remind yourself to connect back to the x-axis. So when you go to find that reference angle and label the sides, the triangles always look like part of a bow tie. Okay, so when you draw a triangle in any of the 4 quadrants, it's got to connect to the x-axis, which makes it look like a part of a bow tie. Here's this part of the bow tie. The next piece is to figure out this reference angle. Now, I've already given you the hint. It's either a 30, a 45, or a 60. Let's see if we can determine what this one is if the total is 240. Now remember, totally I went 240, but that top half of circle is 180. So if I take that 180 and I subtract it out, that leaves you with 60 right here. How do I label the sides if that reference is 60? This would be radical 3, right? Isn't radical 3 always going to be across from the 60? Since this angle is the 30, across from that is a 1, and the hypotenuse is 2. Remember that to get to a point in quadrant 3, you went left and down. Left and down. So these two legs both need negatives. As a general rule, the hypotenuse is always, always, always positive. Okay? We'll always keep that positive. The legs, depending on what quadrant we're in, we'll label some negatives. Okay, finally, we're up to the part where we get to do SOHCAHTOA. Sine is opposite over hypotenuse. The opposite of this reference angle is negative radical 3. The hypotenuse is 2, and that's the final answer. Sine of 240 is negative radical 3 over 2. Okay. Now, as far as checking with all-star trig class, if we're in quadrant 3, we know that tan is the one that's positive, so it makes sense to me that sine is negative. That's all I mean when I say check with ASTC. All right, finally, cosine of negative 315 degrees. Okay, let's see where we are. Negative 315. We're going to start here, but we're going to rotate around clockwise. This would be 90, 180, 270. We're not quite going full circle there. But negative 315 would terminate in quadrant 1. As soon as you do that, connect a triangle back to the x-axis always. Make it look like part of that bow tie. So the question is, what is this reference angle on the inside of the triangle? What's this piece right here? Well, to complete this circle, you can do 315 plus how much would get you to 360, or do 360 minus 315. That would leave you with 45. Once I have that as 45, the sides are 1, 1 radical 2. When I'm in quadrant 1, all the legs are positive because to get to that point, I went right and up, both positive directions. So I don't need negatives on any of the legs. The last piece is considering that cosine is adjacent over hypotenuse. Adjacent is 1, and the hypotenuse is radical 2. So that's what it would be if it didn't say simplest radical form. It seems like that's my goal for you. So in simplest radical form, the final answer there is radical 2 over 2. Okay, if you type this in the calculator, it's never going to tell you radical 2 over 2. It's going to give you the decimal version of that. So when I say to do the exact value when you're evaluating these, it means really sketch the picture and don't use your calculator, as tempting as it might be. Let's try something like tan of 150. Okay, quadrants for 150. Let's see, quadrant 2, it sounds like to me, right? So 150 would be an angle that terminates in quadrant 2 right here. Okay, notice as soon as I draw the terminal side of that angle, I eventually connect it back down to the x-axis. The reference angle, if I'm in quadrant 2, is right here. Think about quadrant 2, what's going on? That completed half a circle. So if half a circle is 180, I got to subtract out that 150. 180 minus 150 is 30 degrees. Now that I know my reference angle, let's label the sides. Across from 30 is 1. Across from the 60 up there would be the radical 3, and then the hypotenuse is a 2. Okay. Do I need negatives to get to this point? Well, when I go left, this should be negative. But if I go up, that's a positive direction. So leave that 1 as a positive. Tan is opposite over adjacent. So that's 1 over negative radical 3. And if we rationalize by multiplying by radical 3 on the top bottom, the final answer would be negative radical 3 over 3. Hopefully you're starting to get the hang of this. Let's do one more before we do something else that's a little bit new. How about secant of 780 degrees? Got a couple new things thrown your way here. Angle bigger than 360 and also the reciprocal function secant. All right, let's see where we are. Secant 780. I know it's going to rotate around once. I know it's going to rotate around a second full time because that's 720. 2 full circles is 720. So then after that, how much further do I have to go to get to 780? It's another 60 degrees from there. So this angle right here is 60 for sure. We've gone 720, 2 circles, another 60 would get me to 780. So once I know that that's 60, across from 60 is radical 3. This side would be a 1, hypotenuse is 2. Okay. Secant's the reciprocal of which one again? We did it up at the top. It's the reciprocal of cosine. So it's going to be hypotenuse over adjacent. So the hypotenuse is 2. The adjacent is 1. So the final answer for secant of 780 is in fact 2. Okay, and by the way, I didn't even have to play that positive negative game because when you're in quadrant 1, all of the trig functions are positive. Okay, a lot more practice to come like this. But then what if I was trying to evaluate something and it fell right on the borderline? Okay, when it falls right about on the borderline, it's called a quadrantal angle. So what about what we call the quadrantals? We need a new process. We can't draw triangles if the angle that I'm looking for is 90, 180, 270, something of that form. Okay. So in order to talk about the borderline, we're going to talk about what's called the unit circle. And the unit circle is pretty important to be able to evaluate sine, cos, and tan of the quadrantal angles. All right, unit circle. Let's see how nice of a circle I can draw. Don't judge me too harshly. Here's that piece of it, and there's that piece of it. That's not so bad. Okay, I'm happy with it. What do we know about a unit circle? A unit circle is a circle with a radius of 1 unit. That makes sense. So if the radius is 1 unit, that means that this distance across is 1. So this is the point 1, 0. This is the point 0, 1. This is the point -1, 0. And then the point down here is 0, -1. Those are all important to label on the unit circle. Okay. Next thing I want us to do is in quadrant 1, draw in any radius you want in quadrant 1. And because it's a radius of the unit circle, I know that this length is 1 unit. Wherever it hits the circle, call that the point XY. Some random point in quadrant 1. From that point, create a right triangle straight down to the x-axis. We've seen that before, haven't we? The angle that's formed, label that as theta. So the angle with the x-axis and your radius length of 1, put that as a theta. And because this is the point xy, I know that I went to the right x and up y to get to that point. So these are all the important labels that you need in your unit circle diagram. And what I want you to do is fill in 2 ratios for me. Figure out what is sine of theta based on this picture. So sine of theta would be opposite over hypotenuse. That's y over 1, which is just y. And cosine of theta would be x over 1, which is just x, right? Adjacent over hypotenuse. So what is this telling me? It means that any point, therefore, any point on the unit circle whose coordinates are x comma y, x could be written as cosine of the angle theta. Cosine theta corresponds with that value of x, and therefore sine theta corresponds with the value of y. And the reason why that's so critically important is we know these quadrantal angles to be the following. 0 degrees is right here. 90 degrees is up at the top. Halfway around is 180. 270 is the angle down here. And then full circle we know is 360. So here's the amazing thing. If I asked you right now, what is cosine of 180 degrees? I know that cosine of 180 goes with the x value of the point on the unit circle where 180 degrees is located. Cosine of 180 is -1. And we could determine that based on this connection that we just made with the unit circle. All right, before we start doing some more evaluating there, what about tangent then? What about tan? Well, tan theta would be opposite over adjacent. So if I use that, it would be y over x, wouldn't it be? And you can use that all the time, that if I were at tangent on the unit circle, I could do y divided by x, and that would give me the ratio for tangent. Also, by the way, if tan is y over x, isn't that the same thing as sine theta over cosine theta? Whoa, we're shocked by that. That's my shocked face. Shock. That's a pretty big idea that we just developed. Tangent is sine over cosine. It's that ratio each and every single time. We're going to see that come up a lot. Holy cow. All right. Let's see if we can do a quick recap of what we know now. So in recap, we know that sine theta is equal to y on the unit circle, which means that cosecant theta, if we had to do cosecant with the unit circle, it would be the reciprocal, 1 over y. We know that cosine theta equals x, and therefore secant is 1 over x. And finally, we know tangent is y divided by x, which means that cotangent would be x divided by y. These are a little bit tougher to remember, but hopefully with enough practice, we'll get used to doing tan and cotangent with the unit circle. Sine and cosine are typically a little bit easier to remember. By the way, x comes before y alphabetically, so does c come before s alphabetically. So that's a good way to remember that. It's cosine first, sine second, if you like little tricks like that. All right, let's do some really quick practice then. What's sine of 90 degrees? When the angle's quadrantal, you're not going to sketch a triangle. You're going to say, all right, 90 degrees is right here. I want you to label that point on the unit circle, 0, 1. Sine of 90 degrees is the y value of that point. It's 1. And that's it. Goes a little bit faster than some of the other evaluating we've done. So then what about cosine of 180? This one I kind of talked about a little bit already. 180 is halfway around. The point on the unit circle is -1, 0. Cosine's the x value there. Cosine 180 is -1. Okay, let's talk about tangent of 270. Okay, 270 is this quadrantal point right here at 0, -1. Tangent we defined as being y over x or sine over cos. So that would be -1 over 0. And when you have 0 in the denominator, that's no good. Tangent of 270 is undefined. So that's a little weird, but we'll find that to happen sometimes with tangent and then the other reciprocal functions. Sometimes they wind up being undefined. Okay. Let's just do a couple more. Cosine of 90. Cos of 90 would be, let's see, 90 is here again. That's the point 0, 1. Cosine's the x value there, so cosine of 90 is 0. By the way, the calculator can help you with this too. Double check it on the calculator, see if it makes sense. All right, maybe just 2 other quick ones. Let's do something like cosecant of 270. So for cosecant of 270, let's see. We're down here, right? 0, -1. Cosecant's the reciprocal of sine. So it's not going to be y, it's going to be 1 over y. Well, 1 over -1 is still -1 as an answer. Okay. And then finally, what about like, let's do tan of -180. When the angle's negative, we know we just go this way. And by the way, -180 and +180, aren't those in the same spot? Okay. Tangent earlier was undefined. Let's see what we get this time. Tan is still y over x, so 0 divided by -1 this time. When 0 is on top, it's okay. 0 over -1 is 0. Okay. So we can do some unit circle evaluating just as easily as we can do the evaluating when we have special angles that are references of 30, 45, and 60. So there's kind of a lot of information being thrown your way here. Some stuff that we're definitely going to have to memorize eventually. Could we generate the unit circle and justify these things? Of course. But I want you to know cosine's x, sine is y, and then we got everything else covered from there. All right, that's it for day 3 here. If you have any questions, let me know. Have a great rest day.